Right, hi folk, let's do a little bit of a gassy calculation. So, first thing to realise is that there's basically two types of gas calculations. The first one, let's find a pen, let's have a flat pen, are the ones that happen at RTP. And on your data sheet you'll find that there is molar volume of gas at RTP and it's quoted as 24 decimeters cubed, and you've done an experiment in lessons where we almost get that value by doing an experiment. Okay, so that's the volume of 1 mole of gas, and the key thing of it's 1 mole of any gas, at least approximately, because gas particles are so far spaced apart the actual size of the gas particle itself has very little impact on the volume until you get to things like very high pressures and you get to extremes of temperatures. This works reasonably well. Okay, that's sort of assumption. So RTP, we can use that figure, and gas questions will specifically say that it's at RTP, and then the expectation is that you look at the data sheet and you use that value. You don't have to remember that value. So for example, if we were doing an experiment where we were doing something like, let's say we put some calcium into water, for example. Okay, so that makes calcium hydroxide and it gives off hydrogen gas, H2. To make that work, you're going to need to have 2 water molecules there. This is a solid and it fizzes when you stick it into water, it floats, it gradually disappears. Initially you won't get any precipitate, but then you get a precipitate because the calcium hydroxide is sparingly soluble. It's lime water after all, so this ultimately precipitates out as a solid because you soon reach the limit of the solubility of the calcium hydroxide and you produce H2 gas. Okay. So calcium has a molar mass of 40, so if we had say 4 grams of calcium, which is a fairly big chunk of calcium to be fair, divided by 40, that would give us 0.1 of a mole of calcium, which would give us 0.1 of a mole of hydrogen, because it's a 1-to-1 reaction. Okay, assuming we did this at room temperature and pressure, and this reaction happens spontaneously at room temperature and pressure, you can say that the number of moles of a gas equals, this is the 24 decimeters cubed mole to the -1 if we want to be a bit more correct. Okay, so this is the volume per number of moles, so we take the volume in decimeters cubed and divide it by 24. So this is quite an important relationship because we'd use this when we're using this RTP figure. So if we wanted to know the volume, all we'd do is 24 times the number of moles, which in this case is 0.1, and that would get us 2.4 decimeters cubed, which is equivalent to 2,400 centimeters cubed. Okay, or just under 2.5 litres. So that's the easy sort of calculation. The other thing that you want to be aware of is because 1 mole of gas has the same volume as 1 mole of any gas, if you've got situations where you've got all gases, you don't even need to think about moles, because moles and volumes, as far as gases are concerned, are interconvertible. So if we take the Haber process and 3 of those and 2 of those like that, these are all gases. So if I had 1 mole of nitrogen, I'd require 3 moles of hydrogen to react with it, and I'd make 2 moles of ammonia. But equally I could say that I've got 10 centimeters cubed of that one, and because moles and volumes as far as gases are concerned are equivalent, because 1 mole of any gas occupies the same volume as 1 mole of any other gas, then we can do volumes in here. So rather than having to work anything out here, I would just say that's going to react with 30 centimeters cubed, because the ratio in terms of volumes and moles is exactly the same. So he would make 20 centimeters cubed. So if you've got a question that just involves gases and we're talking about volumes, then it becomes trivially simple to work out what the other volumes are going to be, because of this equivalence between volumes and moles. We move away from RTP, then we have to use the equation PV equals nRT. And this is an equation where you've got to know the equation, and you've got to know what the symbols are and what the units are. So P is pressure, and pressure is measured in pascals, which is a Newton per square meter. Whoops, getting carried away there. Cubed, it's not a cubed meter, it's a squared meter. And what you'll often see questions quoting pressures in is kilopascals. If you go from kilopascals to pascals, you'll have to multiply by 1,000. That's probably the most common conversion that you'll have to do. So look at the units of pressure very carefully. V is volume, and V is in meters cubed. And we don't often talk about meters cubed in chemistry. We talk about decimeters cubed or centimeters cubed. So we want to do some unit conversion here. To go from decimeters cubed to meters cubed, we need to divide by 1,000, because there are 1,000 decimeters cubed in 1 meter cubed. And if we want to do with centimeters cubed, well, we would divide by 1,000 to get into decimeters cubed, and 1,000 again to get into meters cubed. So if you want to go straight from there to there, you're dividing by 10 to the 6, or a million. Okay, so there's 1,000,000 centimeters cubed in a meter cube. N is the number of moles. That's often the thing that you're working out. R is the ideal gas constant, which is 8.314, which is on the data sheet, so you don't have to remember that. And T is the temp in Kelvin. And the most common thing that you have to do there is go from degrees centigrade to Kelvin, and to do that you're going to add 273. So the key thing about using this equation is getting the units right and looking carefully at each of the numbers that you're given, making sure they're in the right units for putting them into this equation, then working out the thing that you don't know. You always know R. Okay, and the most common thing that you have to do is work out a number of moles of something. PV over RT would give you the number of moles of a gas at a given pressure, volume and temperature. Okay, so this is what you would use to work out the number of moles of a gas if it's not at RTP, but it's often written like PV equals nRT. But you would just rearrange it to find the thing that you don't know. Okay, so you might have to find a temperature. It's most likely that you'll have to work out what a number of moles is. Okay, we'll do quite a lot of questions in the homeworks and the sort of past papers where you have to bung numbers into here, but you generally get marks for putting everything into the right units, putting the numbers into it and getting the right answer, and maybe putting into it an appropriate number of significant figures, and maybe there is something to do with this number of moles afterwards. Okay, so they're basic DF gas calculations for you.